Hello, this is going to be an example solve for the Roux method of solving the Rubik's Cube. So I'm just gonna give a general overview and show you what I would do in the cases that come up here. So the first thing I want to do is um, make a block on the left side, which is going to be my orange since I see some stuff that's already lined up for it. Um, you want to start this most of the time, unless you can just see it, by making a 2 by 2 by 1 and then extending the block. So I put the edge in there because I see this pair right here. So that's my 2 by 2 by 1. And now I'm looking for the rest of that block, which is right here and right here. So what I want to do is make it so that I can match those up like that. And then, oops, insert that to finish off my block right there. So that's on the left side. So now you want to move on to the right block, which is red in this case. So go ahead and move my edge over there because I'm going to be rotating this to make that block anyway. So now I've got that edge in place, which isn't a prerequisite, it just happened to fit in this solve. And then finish off that 2 by 2 by 1 block. And now I see the corner I need is right here, and then the edge I need is right here. And since this is a white corner, I want to move it out of the way so I can do an M2 to bring the block color onto the side so that I can mash this up like a F2L pair and just insert it like that. Alright, so now this is my first two blocks are done, so now I have to move on to CMLL, which is orienting and permuting the last layer. So, or not the last layer, the last corners. So this is a case where you recognize it by the diagonal pairs, and it's a U orientation. There's a matching diagonal pairs, so you want to do R2, B2, R, U2, L prime, D2, L, U2, R. And now you can see that with respect to each other, the corners are all in the right position. So now the next step here is orienting the last 6 edges, and it's just a cyclical kind of pattern you have to follow. Not really a pattern, there's cases that come up and you do an algorithm, which is usually just like M prime, U, M prime, and you get another case and you just do that until they're all your top and bottom color. So my top and bottom are yellow and white, so these are yellow or white, and these are all yellow or white. So that's how you know it's done. So now you want to solve your side edges along with their corners, so you kind of make the two sides. So if you're looking at it this way, you're actually solving the bottom and the top layer, but it's just going to be the right and left side for us. So bring that down. You put them diagonal to each other so that when you do this, they're both on the bottom where it's free to manipulate them to match them up like this. And that was done by putting the opposite corners where the opposite corners of the bottom edge right here, so that when you do an M2 they match up. Alright, so I'll do that. Now you want to permute the last 4 edges, I believe it'll be. So this is just a case where you do that. And so that's a quick example of how at least I solve with the Roux method. I'm sure that there's a lot more efficient ways of doing it, as seen by the fact that I don't average sub 10 like people like Big Green, or close to sub 10 like Tom Barlow and such. But hopefully that helped explain the general idea of Roux to you, and thanks for watching.